All right, we're trying to write the condensed formula for this structure. The structure is up here on the left, but I have drawn it a little bit bigger, and I'm going to expand it here in a minute, and circled all the carbons. All the ends and the bends are carbon, or where more than one come together. And as you're drawing skeletal structures, you want to make sure that you're bending at every carbon. Anything that's a heteroatom, like oxygen, nitrogen, sulfur, etc., chlorine, they have to be drawn. All right. You have to explicitly write an O or an N or an S or a Cl. Carbon is understood, the hydrogens are understood, but anything else has to be explicitly written on the formula. So as I look down here, I've circled all the carbons because I've circled where everything bends. And so I'm going to start here on the left in the upper left-hand side. So I'm going to start here with number 1. And that carbon, all right, that's a carbon, has enough hydrogens to fill up its 4 bonds. That carbon right here is bonded to one other thing currently in the picture, which means there need to be 3 hydrogens to make his 4. Now he's bonded to this carbon, carbon number 2, and that carbon has 3 bonds. Let me clear a little bit here so you can see it. He is bonded to 3 different things. He's bonded back to the first one. He's bonded to the right. He's bonded down and to the left. So he already has 3 bonds. Therefore, he needs 1 more hydrogen. Now, off of this carbon, I'm going to keep going to the right, but there is a carbon hanging off of him. And so I'm going to bring that down and write a carbon. So this is my 3rd carbon. And that carbon only has 1 bond, so I'll need 3 hydrogens on him. We'll talk about typing this in a minute, but now you can see I'm starting to build this structure. Now let's keep going to the right to this 4th carbon. So this carbon, I don't have to draw anything connecting them, is next to the 4th carbon, all right? And he has 3 bonds, so he needs 1 more. So there's a hydrogen on him. And if I go up and to the right, he is attached to a carbon, so I'll draw that 5th carbon. And that 5th carbon only has 1 bond, therefore he needs 3 more hydrogens. All right, let's come back to the 4th carbon, and we'll notice he also has a carbon coming this way. I'm going to come down, and now I'm going to draw this 6th carbon, who has 2 bonds, so he needs 2 more hydrogens. So this is carbon number 6. And he is bonded to a carbon. Here's my 7th carbon. So he's next to a carbon that also has 2 bonds, so he needs 2 more hydrogens. And he is bonded to this end carbon, who only has 1 bond, so he needs 3 more hydrogens. Now, there are several different ways I can arrange this. What I did is I looked at that top structure, and I just followed the chain, hooking off of it when I needed to. I didn't have any oxygens, nitrogens, sulfurs, or chlorine to draw, so it was just carbons and hydrogens. So let me come down here. Let me clean this up just a little bit. All right, it's a video. You can come back if you need to. And now let me draw this more condensed. So anything hanging off can be in parentheses. So I might, for example, let me change colors here. I might start with this 1st carbon and write CH3, and he's only connected to the 2nd carbon, so CH, but the 2nd carbon has a carbon hanging off of him, that is a CH3. Oops. So there is my 3rd carbon. And then I'll come back to my 4th carbon, let me make that a little neater, and continue drawing him, and that is a CH. And then I might draw this 5th carbon, which is a CH3. Whoops. Well, there's 2 different ways I can go here. This 5th carbon is part of my main chain. I can say, ooh, I didn't want to do that. Hang on. I can say this carbon hanging off of him, thank you for bearing with me. Let's come down here to the 5th, is a CH2, CH2, CH3. And then continuing on this chain is a CH3. There is my 6th carbon. So this CH2, CH2, CH3 is this chain. Now, typically, if you remember the lessons about naming these, typically we want the longest chain to name it. So probably a better way to draw this condensed structure is to not have this longer chain hanging off, but instead have it part of the straight chain, in which case I'm just going to flip these two. Let me bring this back down here so you can see what I'm talking about. All right. So as I bring this back down here, all right, the upper left, that was my original. Let me go ahead and get rid of this. You might recognize as you're going through this that my longest chain is here and not that upper right. So I might, when I approach this, I might say, let me approach this as the long chain. That's probably a better way to do it. And so this would be carbon 1, 2, 3, 4, 5, 6. So carbon 1 has 3 hydrogens. Again, for the same reason, he's only bonded to one thing. Let me get the blue. Carbon 2 only has 1 hydrogen because he's bonded to 2 other things. One of them is a CH3 hanging off. And the rest of it continues the chain. So let me continue the chain to carbon 3, which is a CH, because he's bonded to 3 carbons. He only needs 1 hydrogen. He has a chain of CH3 hanging off. And then with number 4, I'll continue my C, and this carbon number 4 has 2 hydrogens. Carbon number 5 has 2 hydrogens, and carbon number 6 has 3 hydrogens. So this is probably, let me grab this and scoot it over. Yeah. All right, I'm just going to do it. This is probably a better way of looking at it. These two are the same molecule. I have my CH3CH to start off. I have my CH3 hanging off. And in this case, I'm going to continue the chain here and make this guy hanging off. So that's a simple, well, maybe not so simple. That's a condensed structure with a couple of branches.